Hey, Algo fam, welcome back. And today, let's solve Dijkstra's algorithm. The thing about Dijkstra is that if you are on the sigma male grind set and you are grinding DSA, then you will obviously come across Dijkstra's algorithm. Mainly because it was one of the most influential algorithms to be written. And yes, now let's go over it. The main ideology behind Dijkstra is to find the shortest path between the node and its neighbors, rather than its neighbors from a starting node to all given nodes in the graph. And so how does it work? So for this there are some prerequisites, like I hope you know what is dq, or I know, yeah, dq is important, but majorly you need to know what is heap and how does heap function. So if you don't know what is heap, then I'll give a bare overview of it. Heap is a kind of binary search tree, which has special properties called shifting up and shifting down, which makes sure that depending upon the type of heap, like for example if it is a min heap, then the top of the heap or root of the binary tree will always be the smallest value, and if it is a max heap, then the root of the binary tree will always be the largest value. And on insertion or deletion, the what will happen is the tree will automatically shift itself and always maintain the heap property. And yeah, which is what kind of heap you're using. So yeah, knowing heap is important. And the thing is, majorly the given nodes will be in the form of adjacency list, and you have to be able to construct a graph from it. And to construct a graph, you have to know what is heap queue, and not heap queue. You have to know what is a dq, and you have to use default. You can use default dictionaries to construct a heap. Construct a graph. So yeah. So how does Dijkstra's work? So what will happen is you will be given a source node, and you will be given an entire graph, and you have to find the minimum smallest distance between the source node and all the remaining points. For example, from 2 to 1 there is only one distance, which is 3. Yeah, it will be a weighted graph, and the distance will be the weight of the graph. Yeah, so from 2 to 1 the distance is 3, and from 2 to 0 the distance is 6. But there is another way to reach 0, and that is through 1. So you can go from 2 to 1 and 1 to 0, and that total distance will be 3 plus 1, which is equal to 4. So yeah, for index 0 or the node 0, the distance is 4. For index 1, the distance is 3, and index 2, which is 2 itself, the distance will be 0. Because yeah, if you are standing on the same spot, then there's no need to traverse and all. So yeah, what is the basic ideology behind it? The basic ideology behind it is to create a min heap having source as its topmost value, and then what you'll do is you will pop values from the heap, from the top of the heap, and then you will check the distance between that and the source value. And if the distance is less than the original distance, or for that also again you have to do some pre-computation. Like for example, you have to declare a distances array which will have infinite distance to each node, but to the current node which you are standing on, you will keep it as 0. And while iterating through the heap, you will check if the current distance, or that it's called tentative distance, and if the tentative distance is less than the distance at the position node. Or if so, for example, if you're standing on node 2 and you pop out 1, then you will check. So what will be the initial array? It will be infinity, infinity, and 0, because the position 2 is 0, and other distances you will initially consider to be infinite. And then what you will do, first you will add 2 to the heap, and then you will pop 2 from the heap, and then go through its neighbors. So first you will go to 1, and you will see, okay, the distance at position 1, how much it is infinity. And then you will calculate the tentative distance as the multiplication of the weight, and you will see, okay, the distance, that the tentative distance is 3, and the original distance is infinity. So what you will do, you will replace that with 3. This value should always be minimum, and then you will add its neighbors to the min heap. Yeah, and you continuously go through this procedure, and at the end of the array, at the end of the heap, when all the elements are popped from the heap, you will have the minimum distances array. And yeah, I found a very interesting video which was explaining how the Dijkstra's algorithm works, and yeah, I will link it in the description. So if you have time, you can check that out also. And yeah, so now directly let's start coding. the main thing which you want is heap. So let's import heap queue. Yeah, in Python you import heap as heap queue like this. And then what you want is you want to create a default dictionary to hold all the data. So let's import the default dictionary also, and default dictionary is present in collections. ICT, yeah. And now what you have to do, first declare a heap, and the declaration of heap in Python is again very simple. It can declare directly as an array. And yeah, first let me print the ADJ matrix for you so that you get to know how it is. Yeah, if you see the adjacency matrix, it is the node and what is the distance of the neighbor. See, this is the neighbor and what is the distance of the neighbor, and the question, it is this question. So yeah, let's write this as the custom input. The given format is two lines, v and e, denoting the number of nodes and edges, and then the three spaced integers denoting the edge and the weight. So yeah, according to this question, the edge is from 0 to 1, the weight is 1, and 0 to 6, 0 to 2 the weight is 6, and from 1 to 2 the weight is 3. And then you have to give the source node. Yeah, let me run that once. And yes, see, the adjacency list is in the format. The index is the node and the first value is the neighbor. So from 0 to 1 the weight is 1, from 0 to 2 the weight is 6, and from 1 to 0 the weight is 1, and from 1 to 2 the weight is 3. And then again the same follows. For 0 to 2 the weight is 6, and from 2 to 1 the weight is 3. Yeah, I hope how the adjacency list is given. So now let's, okay, the naming is very bad over here, let us keep it as source. Yeah, and so now let's generate the adjacency matrix. So how to do that? First what we'll do is we'll iterate through all the matrices, all the, what you tell, arrays present. What you'll do is you'll iterate through all the array, and then to each individual array you'll break it up as weight and the distance, and then you'll add it to the dictionary. So for I in and then for j in range adj at the position I, yes, length of adjacency list at the position I. What you'll do is, what you'll have now is, let me just print out adj at the position I at the position j. Yeah, just look at it once. Yeah, so what you can see is you have the node and the weight, node weight, node weight, node weight, node weight, node weight. So what you'll do is, now you have to declare a default dictionary. So let's call it graph because it's a graph. Yeah, and I hope you know what default dictionary is and what the list inside it means, because I have explained it in one of my previous videos. You can check it out, or you can check any definition. The main thing is you have to know what it does. And then graph at the position I defines the current node which you are, and then to that you will append. Yeah, so what you have done is, to each node you have appended the neighbor and its weight, and yes, this is basically how to create a adjacency matrix, and this is very important to solve graph problems, and it is better to know that. And now let me move all it to its required places. First, now let's declare a heap, and then let's have a distance as array. And again I told you each value of distance should be infinity. Yeah, for in the range v every value is infinity, and what you have to do, the distance at the position source should be 0 because you are standing on the source itself and the distance to the source is 0. So is equal to 0 0. Yes. And now the main ideology is you add values to the heap, and then as I explained, you will pop from the heap, check the distance. If the tentative distance is less than the distance at that at the neighbor node, then update the neighbor node, or else continue, because if the distance is less, that means that we have already found the shortest path and there is no need to check further. So yes, now let's first push the current source to the heap. You want to push the source, and then while source exists, while heap exists, what you have to do again, think through it carefully. What you have to do is you have to pop the heap. So from the heap you have to pop it, and what will it be? It will be the current node in which you are on. So yeah, keep the naming consistent. Don't keep it as A or something, because further down the line you will not understand what A is and you will be left scratching your head thinking where you went wrong in life. So yes, for neighbor and weight, because that is how I have added it to the adjacency matrix. First I have the thing is this is the neighbor and this is the weight, and yeah, we can directly unpack stuff like this in Python rather than writing the index and then collecting the element at that index and then popping it out, or not popping it out, like assigning them. We can directly assign it like this. Yeah, and knowing how dictionaries function is like must for like understanding what is happening over here. So yes, and now let's calculate the tentative distance. Let me call it as underscore distance. So what is the tentative distance? So how will calculate it? Again I have told it is the weight plus the current distance. So what is, how do you calculate the current distance? So it is distance at the position. It will be distance at the position correct node. At the first iteration it will be 2. This will be 2. So distance at the position 2 is 0. And for that you will add the weight of the neighbor node. So again let me go through it. Yeah, you will check the distance over here and you will add this weight to this neighbor, and then you will check if the current distance is less than the distance at the position neighbor, and if you found that it is less than the distance to the neighbor, then it is obvious that you have found a smaller distance. So you have to update the distances array. So yeah, distance at the position neighbor. Distance at the position neighbor is the tentative distance. And since you have found a smaller distance, you have to check all the surrounding nodes also. So you have to push the current node or current neighbor or the neighbor of the current node to the top of the heap. Not top of the heap, you have to push it into the heap, and heap will take care of where it should be placed. Where you have to push into the heap, what you have to push? You have to push the neighbor. And yes, this is basically the entire Dijkstra's algorithm. Yeah, and when you hear it for the first time, you will be shocked, like, oh my god, what is Dijkstra? Oh, okay. For that, to understand Dijkstra, you have to know what is BFS. Okay, what is BFS and all. But yeah, it is very simple if you understand what and how and why. Like what you have to do, why it is happening, and how you can do. And this is the how, and for what and why, it is better you do your own research, because if I start on what and why also, it will take a very long time. So now the distances will be updated with the smallest distance. Yes, and directly you can write return the distance. So let's just compile it once. Okay, I have made some typo. It is, yeah, let me call it distance rather than distances. Keep the naming consistent, that's the main thing. Okay, again, where is that? Line 27, distance. And yes, yeah, let's submit it once. Let's go. Yes, this is how Dijkstra's algorithm works, and yeah, this is a really popular interview question. Like they might not ask you to write the algorithm and all, but they'll ask you what is Dijkstra's algorithm and how it works. So yeah, now if anyone asks, you can tell that yes, I know what is Dijkstra's algorithm. So yeah, thank you and keep on learning.